Very good evening, one and all. Welcome to the series of M.Tech, the Great Amrita Alumni Conclave. Students are all optimistic about their future. Once a student has achieved a great height, we should be proud of him or her to enlighten us about that knowledge. Well, today we have Rashmi Shankar, who will explain about the topic, an overview of artificial intelligence. She is working with Infineon Technologies as a data scientist. She is an Amrita alumni who has pursued M.Tech in data science from Amrita Vishwa Vidyapeetham. So before getting into the session, if any of the participants have any queries, please type it in the chat box. So Rashmi, I welcome you to the session. Therefore, we can start the series. Over to you right now.
Hello all, hope I'm visible and audible. Okay.
Yes.
Am I audible? Yeah?
Yeah, you're audible.
Okay, I will start sharing my screen. Just I made a PPT and all. Okay. So my slides are visible, right?
Yes, it's visible. You can enter in full screen.
Yeah. So good evening all. As he said, I'm Rashmi Shankar. So I completed my M.Tech in data science in 2021. It is 1 year before. So when this proposal was made, like a session to be conducted or to be made, the one thing that came into my mind is to demystify the mysteries behind this neural network. So the thing is, when someone is entering the field of AI, or when someone has an idea of doing an M.Tech or a project in artificial intelligence or machine learning, the first thing that comes to their mind is, oh, it's something that is similar to human brain and it's very complicated. So there is a lot of maths involved in it. So there are a lot of negative things that comes into our mind, which stops us there at that point without going forward. So actually, it is a mimicking. It is adapt, like what to say. So the neural networks are created from the idea of human brain. But human brain is actually complicated. Neural networks are not complicated. It just involves small maths principles, small math techniques that we study throughout our first standard to 10th standard. So I'm not going to explain the complete neural network, the complete math involved in neural network. I'm going to take some simple one thing and just show it to you how simple it is, so that you can just broad your mind and start working with this neural network. So that's the target of this presentation. So we'll start in a wider manner, and then we will go to the one math principle that is actually involved in a very big way inside this neural network. So yeah, so I don't know who the participants are. So the PPT is completely for all. So if you are a person who didn't take M.Tech in data science or who didn't take M.Tech in AI right now, but still if you are in the session, you can hear to this. So this is like for all, for anyone who has knowledge in basic maths and computer science. So the basic thing is, who can learn AI? So the answer is actually anyone can learn AI. So whoever has a basic maths knowledge, the basic maths, how basic it is if you have a proper idea about the addition, subtraction, multiplication, not even division, and some knowledge about this calculus, derivatives and all. So if you're going into this calculus and derivatives, it's not like a differentiation of a huge function or something like that. The whole, the AI, the whole machine learning will be handling basics of derivatives and calculus, like if you are aware that differentiation of 2x or x square values, then you're good to go. And of course, you will be required to have some coding skills. If you're strong in one code, let it be Java, let it be Python, or if you're strong in one particular language, then it's an additional benefit to you. And of course, you have to have a very strong domain knowledge. So whatever field you are from, if you are from mechanical, if you are from electrical, if you are from any other field, but if you have a strong domain knowledge, if you know what is happening in your field, and if you want to add a small component of prediction or small component of machine learning into your project, then if you know some maths and some coding skills, you're actually good to go. So yeah, so as I said, we'll start in a broad manner, and then we will dive into a particular thing called neural network. So before going into neural network, so what is data science? So data science is actually a very huge topic. So there comes data collection, a different field, data pre-processing, an entire field, data visualization and understanding, another total field, and then comes a thing called modeling and prediction. So what we are going to focus today comes under modeling and prediction. So under modeling and prediction, we have something called machine learning. So we will see what is this. So when we start with this topic, many persons use many terms to explain what they are doing. So some used AI, some used machine learning, some use deep learning, some use something called neural networks, and so on. So what is the difference between all these? So actually, again, similar to data science, artificial intelligence is a very big thing. So under artificial intelligence, we have something called machine learning. So under machine learning, we have something called deep learning. So this is the arrangement that is to be seen. So if we can't just put the entire artificial intelligence under data science, similarly, the whole data science doesn't come under artificial intelligence. So I can say this data science curve and this artificial curve may intersect at some points, and that's it. So AI is a very big field. So whatever we are learning, whatever we are studying as neural networks, it comes in a very subfield called deep learning that is inside machine learning. So this is the difference between three of this. So as I said, machine learning is again a very vast field. So under machine learning, we have something called a tiny deep learning. But under deep learning, again, we have so many kinds of algorithms, so many kinds of architectures, and so on. So, so this is not as simple as what is seen in the screen, but I have made it as simple as that so that it will cover the whole population. So under deep learning, let's say we have three kinds of data set. So we have something called a numerical data set or statistical data set, just numbers and its corresponding y values. And then we say we have some image data set that is completely labeled image data set, like cat images labeled with cats, dog images labeled with dogs, and so on. And we have something called time dependent data set. So this is a huge field. Like time dependent means you can say audio, video, so all these things comes under this time dependent data set. So if we go like that for numerical data set, if you have a numerical data set, we will work with something called multi-layer perceptron, or it is called simple neural network. Okay, so if we have an image data set, we will go with something called convolutional neural network, and if we have time dependent, you will go for recurrent neural network. So for every kind of data set, there exists a model, and in that model you have to fit your data set and train it. So among this, again, we are going to go deeper only with this simple neural network. So yeah, this is how a simple neural network looks like. So it will be having an input layer, it will be having an output layer, and it will having layers of hidden layer. So here each circle, so each circle is called a neuron. So this is the only place where human brain and this neural networks are related. It's related just in a structural manner. So if you look at like this, in our human brain also, each neuron is connected to all other neurons in a very complicated structure. So likewise, here also, every neuron is connected to almost every other neuron. So that's the only similarity between this neural network and the human brain. The neural network works nowhere near to the human human brain. Like a human brain is a different concept, and neural network is purely based on maths. So if you can see the structure, it's actually very complicated. It looks very scary. And these are the myths associated with the neural network, or if you start studying deep learning. So it works like a human brain, so it's very complicated and it requires some deep maths knowledge. And you can't develop the entire code from scratch. It's very difficult to do it. So these are the things that is associated. We'll try to break it. And so before going into, like, as I said, we will focus on one tiny, strong math concept that is involved inside this single neuron. Okay, so what happens inside this single neuron? So what happens inside that particular single neuron is something that we studied in 5th grade. So okay, so let's solve this problem. Okay, so when x equal to 1, we have they say y equal to 3, when x equal to 2, y equal to 5, and when x equal to 3, y equal to 7. So these are the things that are given to us, and they are asking us to predict y or solve y, which was the right term. Like they will give solve y when x equal to 10. So what we will do in this? So the first thing we will do is we will, since it's a linear thing, so we will take y is equal to mx plus c, which is a regression equation. So we will try to find the terms m intercept, I mean some m slope and c intercept. So either we will draw a plot the points and then draw a line and then we predict, or we can use this equation called y equal to mx plus c, and then we used to find what's the value of m, what's the value of c, and then we will find the equation. So from these data points, we found out that equation is y equal to 2x plus 1. This is some basic stuff. So with that equation, we can substitute the required x, and then the y can be predicted. So this is something we studied a long back in earlier days. So actually this is a ML model. So this will be the first thing you will be learning in the, if you are taken M.Tech in AI or M.Tech in data science and so on. So this is actually a regression model, which is a very powerful concept in the field of ML and AI, ML and deep learning. So what is happening in here is actually we are summarizing the data. So whatever data is given to us, we are trying to summarize the whole data with a line or a plane or a curve or whatever it is, and then we are trying to predict the asked x. So that is what is happening. So the thing is here, it's a monomial, and it's a linear, and it's a 2D thing. So it's actually very simple thing. So this is just ignore all this stuff. So let's say the red, don't read this equation y is equal to 2x plus 1. Just assume it's not given. What is given is we have given a line, a data points. So red are all data points. So what the data points say, if x equal to 2, it says y is 5. So on, it's a continuous scattered of data. So our task is to find which line fits perfectly to this one. So what we are doing is we are just assuming y equal to x plus 1. Why? Because it's a straight line, and we know straight line can be represented as mx plus c, but we don't know what is the value of m. We don't know what is the value of c. So we just write y equal to mx plus c, and then one shortcut method is like we can substitute different values for a and find which value perfectly fits for the given data. So with whichever point perfectly fits for the data, that particular A will be taken, and that A and C will be used to predict further. So this is how usually things are done. So what if the data that we have is not linear as we see? So what if it's a non-linear data? What if it's not a straight line, but a curved line or curved plane? What if a data like that? What if the data quantity is huge? Here we can see we are given with 3 data. What if we have millions of data, millions of inputs, millions of data sets, and we have to find the curve that perfectly fits the data, and the data is also non-linear. What if it involves polynomial? So there we see mx plus c. What if it's like a sine cube x plus cos cube x plus and so on. So what if it involves a huge number of things? And what if it involves an n-dimensional input, n-dimensional output? So here we can see we have one single x, we have one single y. What if we have 3x, like the height, weight, and some other x parameter of a person, and then we have to predict whether the person is having sugar or not, whether the person is having BP or not. So it's not like we have one single x and one, but we may have multiple x and multiple y. So what if the scenario is like this? So let's again take this example. Again, just ignore this graph and all, and just ignore this summation of this thing also. So what we want to do is like assume this purple line is the data that is given to us. We are just received the data from a data scientist, and we have just plotted the data, and it looks like a square wave. Okay, so our task is to find a perfect function that fits the data, but we don't know the function. That's the thing here. We don't know that the function is summation of n equal to 0 to 100. So just ignore the line. So we don't know that the function is that. What we have is just a square wave. So what we can do is we can assume a function, a simple function as such, 1 by a sine of ax, and then we can see how it fits the line. Let's say, so this is the actual, okay, let me just put it for 0. So assuming all the values to be 0, this is how the function look like. Okay, so what is our task is to so what is our task is to fit the curve. Okay, I don't know why it's not working. So the task is to fit the curves, to find the right A, B, and C value. So the thing is, how to find the similar function? Like, how can I say it's 1 by a sine of ax, 1 by b sine of bx? How to design this function? This is actually a huge task, because it's just a square wave. For even a square wave, designing a function and then finding the values of a, b, c is very complicated. So what if we have much more complicated graph or much more complicated data set? So there comes the neural network. So what neural network does, you simply have to pass all the data set you have inside the neural network. The neural network with itself design a function, design a function that summarizes the data, and itself, and while training, it will find the right value of a, b, c, and so on, if it has so many variables. So you don't have to do anything. You have to just simply design it and sit, and the neural network will take care of everything for you. So this is what the neural network does. So it is nothing but a complicated and simplified version of what. So what is complicated? Because it's non-linear, it's huge, it's polynomial, and so on. But what's simplified? Because you don't have to find the function, you don't have to find the graph y equal to mx plus c might fit the curve. You don't have to say anything to the neural network. The neural network can itself evolve, it itself can understand the data, itself can design a function, and itself can tune the proper value for each variables. That is, it can optimize itself. So all you have to do is design the thing. So yeah, so at the end of the day, what a neural network does, it just summarize and understand the data. Actually, this is what linear regression also does. So the one thing is, it's not as simple as we see, because here we just assuming the data is linear and two-dimensional. So if the data set is linear and two-dimensional, this one single circle will be just having one regression model running behind it. But as things gets complicated, there will be some non-linearity to the system. So it won't be a normal regression function, but the basic will be a regression thing. So this is how a neural network works. I hope I have broken it, not complicated. I hope I didn't complicate the things. So yeah, so at the end of the day, what I'm trying to say is there are so many max, small max concepts involved, but if you look at all together, it looks like a complete mess. But if you separate it and look as each topic as a small topic, actually it involves some basic calculus, as I said, basic all these basic things will be together. So the myths. So as I said, it works like a human brain. No, it doesn't work like a human brain. Human brain is a very complicated thing. Neural network is not even close to it. So it's just that it shares the structural similarity, and few names are taken from human brain, like neurons and all sorts of. And the neurons of human brains, the neurons of this neural network, both doesn't work the same manner. So this is a very complicated mechanism. This is a very simple mechanism. So it's like not any magical math knowledge, or you don't even need to learn new math techniques to understand this. It's all like we have studied throughout the first standard to 10th standard, not even +1 +2. Just ignore +1 +2. Whatever you studied till 10th standard will be highly enough to study neural network or data, this machine learning. Difficult to develop on our own. Yes, actually it's difficult to develop on our own, because the fact is, if we sit and create each node and we have to design function for each node, it's actually very tough. So but on the other side, we have too many libraries available. Let's say in Python there is too many libraries. We have to just pick and use the right library, design the function according to us, and then run it. So it's not that tough. It's just that you need some right resource and right guidance. You're good to go. So before the conclusion, like we are going to the end of the PPT. So before going that, just one difference between machine learning and deep learning. So the deep learning is if you are not so lazy, and also if you have limited data, machine learning is the one thing to go. Machine learning has so many algorithms in it. Machine learning uses Bayes' theorem, which we studied in probability, and some statistical principles and all. So what is there in machine learning is we have to extract features. So let's take an example, like we have to detect whether the given image is a car or not. So if you are using some machine learning techniques, because you have some low amount of data, so if you are using machine learning technique, you have to extract features by your own. You have to extract whether it has a window, whether it has an antenna, whether it has a wheel, and so on. So you have to extract all these features, and then you have to feed the details to a algorithm, and the algorithm will study it and predict whether it's a car or not. Whether in case of deep learning, you don't have to do anything. You have to just simply dump all the data that you have inside the deep learning, and each neuron, as I said, each circle will try to extract the features on its own. It will extract whether the car has a structure similar to antenna, whether it has a similar to two doors, and so on. So it will extract the features on its own. It will summarize the data, and the trained model can be used to predict it. So these two are the difference. Then you can ask, so what is the purpose of machine learning when we have deep learning? So the thing is, deep learning consumes a high amount of energy. So only if you have a data set that is huge enough to train a deep learning, then only you can use deep learning. So, but machine learning, even if you have 10 data set, 10 car images and 10 not a car images, so you're good to go with machine learning. But deep learning involves a high amount of data, high amount of processing, GPU, and so on. So recent trends in deep learning. No, I didn't dropped any papers, recent trends, and all. What I'm trying to say in this picture is how the trends are developing in this deep learning field. So as I said, it's not each data in what we will get is like, okay, purely time, but in real world won't be the scenario. So we can be getting mixture of two data sets. So we may get data set of images and a time dependent data set. So yeah, in that case, we'll be using a combination of CNNs and RNNs. So the research is going on like this, how to combine two networks, how to become more efficient. So the things are going like this. And also under each algorithm, they are making the algorithm more efficient. And also there are like millions of parameters involved in designing. So how each parameter contributes to the neural network, and how each parameter can be much more optimized, and so on. These are the trends that is going on in deep learning. It's just like they are evolving and evolving, and they're finding the best solution for the given thing. So The last thing is, if you are a person who is interested to add a machine learning component to your project, like if you need to predict something, like your 80% of the project is not machine learning, but just you have to add a 20% of machine learning or AI or something to your model, then you don't have to spend a long time in AI if you are not a M.Tech in data science or AI student. But if you are other student who's interested in this one, so what you can do is you can just go through this AI from Coursera. Sometimes Coursera is available free for Amrita students. So we can just study this basic course, and then you can build your own data set, or you can take data set from Kaggle, and you can get code from several several websites, and just understand some basic maths behind it, and you can add that model to. It's not like if you are an not a M.Tech data science or AI student, still want to. So for those students, this much is okay. You will be able to understand the concepts of math because it's actually easy. For students who are belonging to data science and AI, certainly this won't be enough. So you have to really dive into the neural network concepts. You have to learn everything, each and everything. Just understand it, just learn it with passion, so you won't find it difficult. And it's actually a very good field to learn. Some useful website. This is for both if you're data science or not a data science student. So this website's almost cover all the things that is involved. Yeah, so we have a very perfectly designed syllabus. Other than that, these websites will be useful for you. And okay, so this is it for the neural network. So I just wanted to share my 4 things to you. I assume the crowd is M.Tech new joinees. To those students, this is just my 4 opinions. So what is it like? There is a rule that we have to publish a paper before before completing the M.Tech. So what I would suggest is start publishing a paper in the first semester or second semester with a PhD scholar. Just go to a guide and talk to them and ask whether you can join a PhD scholar and try to publish it, because it will teach you how to publish it, how to actually find a journal, how to find a conference. Because at the end of the second year, you will be under a lot of pressure. Like you have to go to internship, you have to finish the project. At the same time, you have to publish a paper. It will be too much to handle. So right now, since you have only courses to be completed, just try joining with a PhD scholar and start publishing a paper. It will be really helpful in the future. And explore facilities. Of course, actually we didn't had so much time in Amrita because COVID came. So we had like 5 months in campus. So since you're lucky students who are actually in campus, I guess, just for particularly for data science and AI students, just try exploring the facilities. They have a actually GPU in Bangalore campus. Just know how to get access to it. Just they have really huge servers and all. So just go through it and put some data and train your model and see how it works and all. It will actually be useful if you go for a company. And the third thing is choose your electives wisely. And particularly if you're a data science and AI student, you should actually choose really wisely. Sit together in your class and take all the electives and discuss with among your classmates, and then choose. Don't be like at the end of the semester, just take 2 random electives and say, okay, we'll go with this. Don't do that. Just take a broad. So how much you cover in data science, that much is beneficial for you. So try to cover as much as concepts as, even if you are not strong in everything, it doesn't matter, because data science is a very strong, very detailed one. So you can't cover everything, but try to cover as much as everything, at least on the top layer, so that in future, if you want that something in your project, you can learn in a detailed manner. So try to choose in a wider way. And the last thing is students from different disciplines. So basically, I did my B.Tech in robotics, and then I joined M.Tech in data science. So I know nothing about computer science. I know something about programming, that's it. So I took the course because I was interested in it. So later I found many like me were in the course, like some were mechanical and some were electrical, joining M.Tech data science and all. So if you are a different discipline student taking a different course, or if you are a student who has joined M.Tech after a long gap, so if you have completed B.Tech 5 years back, 10 years back, you've taken some time to work and then you again joined M.Tech. So these students, you may find it difficult for 2 months or 3 months, but the faculties are very much friendly. You can approach them anytime and you will get used to it in a matter of 3 months. So don't quit in the middle. It may seem tough in the beginning, but you will get to it. So yeah, these are the 4 things from my side. And all the best to you all. And if you have something, or if you have any doubts or anything to be discussed related to data science or something, you can, this is my email ID, you can just send a mail and I will mail you back. So yeah, this is it. Thank you from my side. I hope the session was kind of opening to data science.
That was a very nice session, by the way, Rashmi.
Thank you.
And so one of our candidates has asked, what's the future of AI?
Okay, so to be honest, the future of AI, the research side is actually completely filling with a lot of research papers. So the research side is like, what to say, the basic algorithms are all created. So what is happening is so much of updation, so much of optimization techniques are having are taken place in the research side. But if you see in the application side, there is a whole lot of field to you, because we are just started to apply the research concepts into actual product things. So if you go there and look, there is a lot wide of opportunities, but on the research side, it's actually very tough to publish a paper because it's highly competitive field. Yeah, it's a good field actually.
All right. So what courses can a person pursue if he's interested in AI?
Okay, there are a lot of
B.Tech in AI.
yeah,
like cybersecurity, we have like that. Even cybersecurity, right?
Yeah, actually, yeah, can you read the question again, or can I see the question?
If a person is interested in AI, so
Okay.
what courses can he pursue?
Okay, so this is from a B.Tech student.
Yeah.
Okay, yeah, as I said, just give it a try in Coursera. Just try it out whether you like the field or not. Just read 1 or 2 videos or see 1 or 2 videos and just look whether you're comfortable with it. So many are like they see data science, oh, if everyone is taking data science, so if everyone is taking this magical artificial intelligence, so let's also go into it. But later joining, they feel that's not their cup of tea. So I'm saying just try it out for a little bit, and if you still are passionate about the field, go forward to it. The only thing to understand artificial intelligence is you have to be open-minded. You should be ready to learn anything, and you should be really passionate about what you're learning. So these two will satisfy the criteria to enter into the field, no matter what B.Tech degree you are.
So what two languages do you need to know about AI when looking into AI?
Okay, I prefer Python. So Python is the one go-to language for me. But right now there are many languages developed that is actually efficient more than Python. But Python is actually good to go because as a data science student, you will be learning data structures and many other concepts. And Python can be applied to all the subjects. So if you are good to go, I mean, you're strong in Python, you can go with Python. And later on, if you feel like some other languages is efficient than Python, then you can jump to it. It's not a big deal. But Python is sufficient to study AI and ML.
All right. Thank you. Thank you, Rashmi. That was a fabulous sessions. Thank you so much.
They said, please put your PPT. Okay, on full screen. Okay, it's back, long back. Sorry for that. Yeah.
Thanks.
Okay.
Right. Okay.
Yeah.
Okay, then let's call it a day.
Thank you.
Thank you, Ji.
Thank you.